So we need to find the magnetic field at point P. I'll start with I2. Okay, so if I draw a line that goes from I2 and connects with point P, the magnetic field is going to be perpendicular to that line. It's going to make a right angle with that line. The right-hand rule tells me that the magnetic field around I2 curls around it like that in a counterclockwise direction. So that means at this point, the magnetic field due to I2 points in that direction. Now for I1, we draw a line that connects I1 with point P. Ooh, that's not a very straight line. Sorry about that. Well, the magnetic field due to wire 1 is going to be along this line that's perpendicular, right? Okay, so I need to find R1 here. Now R1 I can find using the Pythagorean theorem. 0.33 squared plus 0.19 squared, so that's 0.381. And I'm also going to need this angle theta here. Theta is inverse tangent of opposite over adjacent, which is 30 degrees. Okay, so that means this is 30 degrees. Looking at the field surrounding this current, it goes around counterclockwise, so that means it's going to go up like this. And here's B1. Okay, so, well, if I continue this radial line, R1, I know that this angle here is 90 degrees, and I also know this angle is 30 degrees. So that means this angle must be 60. Right? There are a lot of ways to deduce that this angle is 60 geometrically, but the point is that this line here has to be perpendicular to this line, and that helps you get to the 60 degrees. Alright, so now we've got the magnitude and direction of B1 and B2. So let me find the magnitude of B1. That's mu naught times 5 over 2 pi times 0.381, which is 2.6 microtesla, and that's directed 60 degrees above plus x. And then B2, well, that's mu naught times 5 over 2 pi times 0.19, so that's 5.3 microtesla directed in plus x direction. Okay, so B1x is 2.6 cosine 60, which is 1.3. B1y is 2.6 sine 60, and they're both positive, right? I'm going with my sign convention. The up is positive and to the right is positive. So the x component and the y component are both positive in this one. That's 2.3. The x component of B2 is just B2, which is 5.3 microtesla. And the y component of B2 is 0, since B2 points directly along the x-axis. So this totals 6.6 microtesla, and the y component totals 2.3. That's our total vector. Okay, so if I make a little Cartesian coordinate system here, and if I go out 6.6 in the plus x direction, and I go up 2.3 in the y direction, then I get my total magnetic field vector. So to find the magnitude of that, I use the Pythagorean theorem. That's 7.0 microtesla. And then to get the angle alpha here, alpha is inverse tangent of opposite over adjacent, so that's 19 degrees above plus x. Okay, so there's my overall answer.